Dams are often seen as symbols of human ingenuity, harnessing the power of nature for our benefit. However, these structures come at a steep environmental cost, profoundly altering the delicate balance of river ecosystems. By blocking the natural flow of water, dams disrupt sediment transport, alter water temperature, and fragment habitats. These changes have cascading effects on aquatic life, leading to declines in biodiversity and overall ecosystem health. One of the most significant impacts of dams is the alteration of natural flow regimes. Rivers are dynamic systems characterized by seasonal variations in flow that shape their physical and biological characteristics. Dams disrupt these natural flow patterns, creating artificial reservoirs with stagnant water and altering downstream flow regimes. This disruption can lead to changes in water temperature, dissolved oxygen levels, and nutrient cycling, impacting the survival and reproduction of aquatic species. Furthermore, dams act as barriers to sediment transport, trapping sediment that would naturally flow downstream. This sediment is essential for maintaining downstream habitats, including spawning grounds for fish and nesting sites for birds. The accumulation of sediment behind dams also reduces their storage capacity and can lead to increased erosion downstream as the river tries to regain its natural equilibrium. The environmental burden of dams extends beyond their immediate impact on rivers. The creation of reservoirs often inundates vast areas of land, flooding terrestrial ecosystems and releasing greenhouse gases as submerged vegetation decomposes. Dams can also contribute to the spread of invasive species, which can outcompete native species and disrupt food webs. In essence, dams represent a significant human-induced alteration of the natural world, with far-reaching consequences for freshwater ecosystems. If you found this information valuable, please like, comment, and subscribe to help our channel. For millennia, fish have navigated the intricate network of rivers and streams, their migrations intricately tied to the rhythm of the seasons. These migrations are not merely journeys, they are essential for spawning, feeding, and maintaining healthy populations. Dams, however, pose an insurmountable obstacle to these ancient journeys, disrupting the delicate balance of life in our waterways. Salmon, in particular, are iconic for their epic migrations, traveling hundreds of miles from the ocean to their natal streams to spawn. Dams act as impenetrable barriers, blocking their upstream journey and severing the vital link between freshwater and marine ecosystems. The consequences of this disruption are severe, leading to declining salmon populations and impacting the entire food web. The construction of fish ladders and other passage structures has been attempted to mitigate the impact of dams on fish migration. However, these structures are often ineffective, failing to replicate the natural flow conditions that fish rely on for navigation. Moreover, even if fish successfully navigate upstream, they face the challenge of returning downstream, often encountering turbines and other hazards at dam sites. The impact of dams on fish migration extends beyond salmon. Many other fish species, including shad, sturgeon, and eels, rely on free-flowing rivers to complete their life cycles. The fragmentation of rivers by dams disrupts these migrations, isolating populations and reducing genetic diversity, making them more susceptible to disease and environmental change. The Klamath River, flowing from southern Oregon to northern California, stands as a testament to the destructive legacy of dams and a beacon of hope for the future of river restoration. For over a century, 4 hydroelectric dams have choked the Klamath, decimating salmon runs that were once the lifeblood of the river and the indigenous communities that depended on them. Now, in a historic effort, these dams are slated for removal, marking the largest dam removal project in history. The removal of the Klamath dams is a monumental undertaking driven by a coalition of indigenous tribes, conservation groups, and government agencies. The project aims to restore the Klamath to its former glory, reviving salmon populations, improving water quality, and revitalizing the entire ecosystem. The benefits of dam removal on the Klamath are expected to be significant. By restoring the natural flow of the river, the project will reconnect salmon to their historical spawning grounds, allowing them to complete their life cycle unimpeded. This, in turn, will have ripple effects throughout the ecosystem, benefiting predators, scavengers, and the overall health of the river. The Klamath River Dam Removal Project is not just about ecological restoration. It is about righting historical wrongs. The construction of the dams had a devastating impact on the indigenous communities who have lived along the Klamath for millennia, disrupting their way of life, their food security, and their cultural heritage. The dam removal is a step towards environmental justice, acknowledging the injustices of the past and working towards a more equitable future. The ambition of the Klamath River Project is not without precedent. Around the world, dam removals are gaining momentum as a powerful tool for ecological restoration. From the Pacific Northwest of France, dam removals are revitalizing rivers and ecosystems. The Elwha River in Washington state is a testament to the power of dam removal. In 2012, the Elwha was reconnected to its headwaters with the removal of 2 dams. The results were remarkable. Salmon returned to the upper reaches, their migratory paths restored. The river reshaped itself, reclaiming its natural rhythms. Forests flourished as nutrients nourished the ecosystem. The Saluna River in France tells a similar story. 2 dams were removed in 2020, restoring connectivity. Scientists observed a resurgence of aquatic life and improved water quality. The Salune is now a living laboratory for dam removal benefits. These stories show that river ecosystems are resilient. They can recover from human impact, offering hope for the future.